Happy New Year and welcome to a very special New Year's Day episode of Packet Tracer with Whale Hater. We're doing Packet Tracer 9412 and this is an update video because recently Cisco changed something. What they did is made this Packet Tracer that much harder. They decided to get rid of everything in this addressing space except for interface listings and the /30 address or network masks. Subnet mask, and they tell you that you got to fill in everything. So what I did was I went through and copied it onto a spreadsheet and gave you the names. So here is in this first block is the router admin. The second block is site 2, site 5, next block after that, those two routers. Then you got your administration switch. Now a lot of people have been struggling with figuring out what the heck's going on here? Why can't we figure out what the switch ID is? Now, if you go through to fill in most of this addressing space, just go through and hover over the routers, and it's going to tell you exactly what things are listed as. For instance, S000 is listed as 10.10.10.117/30. So you got your network mask already. Now you go through and do that, and you're going to get an addressing table that looks a lot like this. We have all that through. Now your names and your addresses are probably going to be different. Like it might be in the 172 range or the 198 range, but I'm just showing you how to figure it out. Okay. Now to do your sub interfaces, you are given those over here. So for VLAN 15, we'll be on sub interface 15. And so on and so forth, VLAN 30, subinterface 30. So you just fill in 10.10.10.16, and then that's the network address, okay? So you're just going to give it the next available address. So give it a 161, and a 193, and a 129, 145. Just go through and address those, and then figure out the subnet masks. And I did that for you already. So you've got your sub interfaces 161 through there. To do the switch, you'll see that he is going to be, well, to manage him, he's going to be on VLAN 60. Okay, so you're just going to give it the next available address. So if on VLAN 60 it's 10.10.10.145 for the router address, the switch is just going to be 146, the next available address. So now we have our fully figured out IP addressing table, and that's something you can turn in. All right, let's get programming here. Without further ado, let's go to our administration switch. All right, configure remote management access, including IP addressing and secure shell. It took me a minute to think of it. All right, so let's give it ourselves an IP domain /name, and that'll be cisco.com. Okay. We want our username to be capital A admin, and our password to be the let me in password. And I think that's the password isn't that the password off that movie Sneakers? Alright, crypto key generate RSA. And that is to be the 1024, looks like. SSH, we want to do a version 2. The authentication retries is to be 2 allowed. Timeout is going to be, timeout's going to be 60 seconds. And that's it for that. Before anything else happens, let's do the one thing I forget most often, default gateway. The default gateway is just going to be that management VLAN 60. 145 is the router's IP address, 10.10.10.145. Okay, clear text password should be encrypted. Service password encryption. Configure, name, and assign VLANs. Ports should be manually configured as access ports. Alright, so we'll go up to our addressing table here for our VLANs. VLAN 15, name servers. These are, in fact, case sensitive, so make sure you type in the correct case. VLAN 45. Alright, so those are done. Let's go to our interfaces now. Interface range F011-220. Switch ports, mode, access, switch port, access, VLAN. This will be VLAN 15. Now we'll just do our up arrows, change that to 1 through 10, turn them into access ports, change it over to VLAN 30. And the last one we'll do G01 trunk, switch port trunk, native VLAN, and that is 45. Okay, so we've configured trunking. We've done all that. Let's go over to our management interface here. Interface VLAN 60. And it changes it to up. We like up. Let's give ourselves our IP address of 10.10.10.146, if I remember, since we had a 145. Yep, 146. I say 145 and then I type 145. Dumb. 240. Okay, we want to do our login local. Oh, what am I doing? That's the wrong. I'm on the wrong thing. Let's exit out here. To manage it through our VTY lines, we have to go to line VTY 0 through 15. Give our login local command there. That's the place to do it. An IP trans. Oh, here. Wait a second. We got. Oh. Transport input SSH, and that's going to allow only SSH traffic to come into the switch, not Telnet. That's less secure. All right, let's go over to implementing port security. So interface F01, we're going to say switch port security. Enter switch port security. Then we'll do maximum allowed addresses is 2. MAC addresses are to be learned dynamically or automatically added to the configuration file when detected. So MAC address sticky. And then the last one, the port should not be disabled, but a syslog message should be captured if a violation occurs. That one is the restrict. We'll do that. Disable all other unused ports. Interface range F0. Let's see here. So these are all of the ports that we used. This is a 24-port switch, so 21 through 24 is not used. Comma, and then we have on this switch a G01 and a G02. So we're not using G02. We're going to do that. So that's the range we're editing right now, and we're going to give that the shutdown command. Alright, we are done here. Let's move on to the rest of this nonsense. Configure inter-VLAN routing. Now what that consists of basically is just doing those sub interfaces. So let's look at our addressing table. Interface G00.15. encapsulation, we're going to give that the 15. IP address is 10.10.10.161. We're going to do one other thing since we're here and we don't have to come back for it. And this will make a little more sense later. I'll explain it more. But it says that we need to implement NAT. And one of the things that NAT needs is it needs to know what are its private address networks and what its public address networks are. To do that, it's a simple command doing it IP NAT, and then we just say inside, since this is going to be an inside private address interface. Wrong button. Okay. Next, let's do our next interface. The IP address is 192, or not 193. The subnet mask is 192. Change that to a 93. Oh, duh. You do the .q. Then we can do the IP address. Then we can do the IP NAT. Then we can go to the next interface. For the native VLAN, we have to give it a special command calling it native. This one is 240, and the IP address here is 29. Get rid of that native, change the 60. Subnet mask is the same. And this is going to be a 145 for this guy. Well, let's do this. 1, 2, 3. Go to the G00 interface and just issue the no shutdown command. So that'll bring up all those interfaces. All right, we're done with that. Let's configure DHCP and see if it works for VLAN 30 and use the LAN as the case-sensitive name for the pool. IP, DHCP, excluded addresses. Always do this first. Exclude the addresses first. Now it's for VLAN 30, so we're going to use this address as our router address, and we want to make sure we do not give that address out. 193, we can just copy that. That'll be helpful later. DHCP pool, and then name it a LAN. Now we're inside our configuration for DHCP. Let's give our default router paste. Then I'll give our network commands. Let's do a network. We'll paste that in there and change that to a 2 since the network is 192. The 192 network right there. And then 255's 192 again. Or the subnet mask. And that one should be done. Let's exit out of there and let's go see if it worked. Did it work? Does Whalehater have any idea what he's doing? Yay, it worked. Let's go back there and let's continue our configuration. Alright, so we did the pool. Now we have to implement the routing protocol. But it doesn't actually, this isn't actually right. So maybe you're frustrated. I did everything it told me to do and it's still not right. If you go through and do the check results, it's not going to ask for RIP. It's actually going to ask for OSPF. Now when they updated this packet tracer, I wished they would have updated this nonsense because this is wrong according to what you're being graded on. So what you're being graded on is router OSPF. That's another routing protocol. I know you probably introduced to it. You get in more into detail the next semester in Networking 3. The routing ID, or not routing ID, rather the process ID for OSPF is going to be 1. The next thing we're going to do is give a router ID, and that's going to be, it looks kind of like an IP address, but it's not. It's just the ID, and that's going to be all ones. The next thing we're going to do is give an excluded or a passive interface, because we don't want updates shared to this network, just to the other routers, right? And a G00 will take care of everything on that interface. You don't have to do the sub interfaces. All right, next let's do our network command, and we're going to pull in everything from the 10 networks. So all of this has all been addressed to 10s, all this is all 10s. So we're just going to do one statement that's going to do all the networks. And that is like this. .0, and OSPF uses, depending on your version that you have on your router, it can use either a subnet mask or a wildcard mask. Better safe than sorry, just use the wildcard mask, and it's just basically an inversion of a subnet mask. So we're using this address, that subnet, well, that wildcard mask for that subnet mask, and then we have to do one extra thing. Area, because OSPF uses areas, and you'll learn more about what those are next semester. We're going to be in area 0. Enter. And I think you're done here, so we can get out of that. Now we want to configure a default route to the internet. Our exit interface is going to be this one right here, so that's an S010. Okay. Implement NAT. Configure a standard one-statement access control number 1. Access list. Standard 1. Okay, so we're there. All IP addresses belonging to the 10 networks should be allowed to access the internet, basically. So everything from over here all the way over here. So we have to do that kind of thing. So we're going to say permit, and we're going to permit anybody from this network, or with that prefix, the 101010, doesn't matter what this is, they're going to be allowed. And we have to use, again, we have to use wildcard masks for this. Enter. And that's going to allow anybody that has a 101010 prefix, like this guy, all of these guys, to go through to the internet. Now, that's just a list. It's not doing anything yet. We have to tie it to an interface and make it work. But we haven't done that yet, and we won't until later. So let's exit out of there. Next, it says we want to refer to our documentation and configure static NAT to the file server. Now, network address translation is we're going to statically tie these two addresses together for the file server. Okay, so IP NAT inside source static. We're going to give the inside address, the private address, the 10 address, because those are not publicly routable addresses, right? It's only locally significant. And we're going to tie it to a globally routable address, this 198 address. 198.133.219.130. Now what that does is, if we open up the file server, you can see that his address is 10.10.10.162. Okay. Now he can't get requests for this address here. For instance, if he wants to contact this file server on this private network, he can't type in 10.10.10.162 because it's not going to go anywhere. It's not going to cross the internet because it's a private address. But if he types in 198.133, that address, it'll go across the internet. Admin will pick it up and it'll say, "Who's this for? 198? I don't know. Oh yeah, I know about that one. I was configured. Any traffic coming for the 198.133.219.130 address is going to be routed to this guy right over here." And that's what that static NAT is about. Okay, who cares? Next thing we're going to do is to configure dynamic NAT with PAT using a pool name of your choice. a /30 mask and these two public addresses. Ta-da! Oh my goodness. Let's see if we can copy those. Copy that. Sweet. All right, to do that, we need to create a pool first. So IP nats pool, and we're going to use a pool name of our choice. We're going to call it pool. Let's see here. We want to give the range that these two are going to be. So we'll paste that in there, and then we're going to delete this and thing. We don't need that. So that's the high address. Here's the low address, and then we have to get, you have to give the network mask, and that'll be a /30. So 255s and 252. Enter. So we created a pool. Now we're going to tie these two things together for accessing the internet. Okay. IP nat inside source list. Okay, the list is that access list that permits everybody from that. So we're going to give him a 1, and that references this list. Then we're going to reference the pool we just created by saying pool. The last thing we're going to do is add a modifier of overload. Now what overload does is it creates, or it doesn't create, it allows traffic to be tagged with port numbers instead of just regular IP addresses. Now if you were just going to use NAT without this overload command, only 2 processes at any one time, like maybe this device over here and this one here, could access the internet, because at one time anyway, because the admin router would say, all right, so this guy right here is using this first address right here, this 128 address, and you know, POS 2 is using this 129 address, so my address space is used up. I can't hand out any more addresses, or at least not right now. Now with PAT, port address translation, most everybody in the network is going to be sharing one address, but all the port numbers are different. So he might have, you know, the 128 address, but the port number 3, and this guy over here might be using the same address 128 and might be using port number 6072, and this guy over here might be using, you know, 35,701, and any of those port numbers would work. Well, maybe not the 2, but anyway, whatever. So we're going to enter that. That way, what we just did is conserve IP addresses. It makes it really helpful. All right, now to finalize the PAT, NAT, whatever we want to call it, configuration, we have to tell the administrative router what ports are on its private address space and what ports are on its public address space. Now we did that earlier with that IP NAT inside. We did that on our sub interfaces. So this interface right here is done. We have to do these last 3 serial interfaces. So interface S000, and we're going to do that same thing, IP NAT inside, because it's a private address, and we're going to do the same thing for S01. Now S010 is going to give the it's going to get the outside command, and that's going to say anything that's the outside world. Outside. All right, we got our 70 points. We are ready to turn this packet tracer in, as well as the awesome job we did on the addressing table. We can turn that in as well. And we're done with the video. Thank you very much for watching. Thanks for being patient with me as well. Some of you have been waiting for this video a while. Hopefully I didn't screw you up too bad. I appreciate your support. I appreciate the views. And please subscribe, share this channel with your friends. Tell them where to get some awesome packet tracer help. Talk to you guys later. Peace.